Hi friends, today we will learn two very fundamental and very important results in trigonometry. We know these formulas, right? Sin A minus B equals sin A cos B minus cos A sin B. Cos A minus B equals cos A cos B plus sin A sin B. These are very fundamental and we derive or we prove a lot of results with this. But how exactly did they come? Let us understand the geometric meaning also and how do we prove this using geometry. Right. Let us Let us take this line OA and then draw another line and a third line. Right. The first, this OB, let it be making some angle A. Right. And then OC, then let it be making some angle B. Right. Now we are concerned about sine A minus B. That means we are concerned about this angle. Right. I'm writing in blue. Sine A minus B is this angle. We are concerned about this angle. Right, total is A, this is A, and this is B. We are concerned about sine A minus B. Okay, we have to find what is this. Right, now there are three lines OB, OC, OA. These are the three lines. OB is making angle A, and OB and OC angle B. And here this is the angle sine of A minus B is what we are looking for. Let's take some random point P on the middle line. Right, and draw two perpendiculars. This is a perpendicular PN and PM. Basically, PM and PN, two perpendiculars on both the lines. Here we are assuming that angle A and angle B are acute angles, but you can do the same thing for obtuse angles also. Just that you need to be a little careful with the signs, positive sign or negative sign. Right. Now, here we have drawn two perpendiculars. We taken a random point P on OC and let's draw two perpendiculars. So this angle is 90 degrees. This is 90 degrees. Similarly, this is also 90 degrees. Then, then from this end, let's draw another perpendicular, this NQ. And from P also, let's extend this perpendicular, whatever PM, let's extend it little backward. Right. And let's draw another horizontal line so that it meets at R. Right. And R is actually parallel to the base, that is QM. Right. Basically, this entire base is a rectangle. And R, M, Q, this is a rectangle. Right. PN is a perpendicular to OB. PM is perpendicular to OA. Right. This is a rectangle. Now, if you see, there are three right angle triangles. Three right angle triangles. What are those? One is OPN. This big right angle triangle. OPN. Right. One is OPN. This is one right angle triangle. Now, what are the legs? The legs are ON and NP. With both of these legs, there are two more right angle triangles. Right. ON, and Q. Right. With this leg. With leg ON. With leg ON, we have O and Q. Right. Similarly, with leg NP, with leg NP, we have this leg. With this leg as hypotenuse. What is that? NPR. NPR. Right. Basically, this big triangle, mother triangle, OPN, it has got two legs. OP is the hypotenuse and two legs. With those two legs, we are drawing two right angle triangles, right, as hypotenuse. ON has become hypotenuse in this ONQ. Similarly, NP has become hypotenuse in this NRP. Right, we have got two right angle triangles created out of the two legs of the big mother triangle, which is ONP. Right. Now let us see what are these angles. Right. This is a right angle triangle. So this O, let's take this ON, OQN. If this angle is A, this angle is A, this should be 90 minus A. Right? This should be 90 minus A. Whatever. Let's see if it is alpha. 90 minus A, whatever it is. Now, this angle is again 90 degrees. Right? This angle is again 90 degrees. That means this one should be A again. Right? Because this is 90 minus A, this should be A. Right? This is 90 minus A, 90 minus A. Then this should be A again. Right? So we have figured out this angle is A. This angle. If this angle is A, this should be A. Why? Because this part is 90 minus A and this total part is 90. So this should be A again. Now let us take these two lines. This is this and this. These are parallel lines, right? Both are perpendicular to the base OA. So these are parallel lines. And let's take this one. This is a transversal, right? So this angle and this angle should be same, right? Opposite angles, right? And this transversal. So this angle and this angle should be same because these two are parallel lines. So this is A. So this and this should be same. So then this also becomes A, right? Now let's keep it like this. We know this is A, and so overall is A. Now what is sine A minus B? Sine A minus B is sine of this angle, which is, what is the sine of this angle? This entire MP by OP, right? In this triangle, OPM, which is also another the fourth right angle triangle, right? We have figured out 1, 2, and 3, one fourth right angle triangle, right? This is the fourth right angle triangle. The sine A minus B is PM by OP, right? PM by OP. That's what we have written. PM by OP, MP by OP. Now, what is MP? MP is total RM minus PR, right? This total line minus whatever the small line. If you remove this, then this is what we get. So let's write it like this. MR, this is the total line, minus PR, minus this part, right? That is, we can write it as PM, right? PM is MP. Now let us just open this. What is MR? MR is the total line, and this is a rectangle, which is equal to NQ, right? MR equals NQ. Right. So then this becomes NQ or OQ by P minus PR by OP. Right. QN by OP versus minus PR by OP. Basically what we are saying, QN, this one, by OP, these two lines. Right. Now let us do one thing. This line NQ is part of this right angle triangle. Right. And OP is part of the mother right angle triangle. Right. Let us do one thing. The between these two triangles, what is common? This ON is common. Right. ON is hypotenuse of one triangle and leg of another triangle. So just let us just multiply and divide by this ON, the first term. Right. This QN and OP, we are taking this QN and OP, QN by OP. Let us do this thing. Right. QN by ON. Right. That is this one. Because this is common between these two triangles. Into ON by OP. ON by OP. Right. That's what we have done. So because anyway ON will cancel, we just wrote QN by OP in this form. Qn by On into On by OP. Right. Now similarly, PR by OP. What is PR? Let us erase everything. PR is this. PR. PR by again the same OP. This is what we want. Now, this is part of this triangle and PR is part of this triangle, right? NPR. And OP is part of OPN, right? And what is the side that is common between these two? That is this NP. Right. So let us do the same thing. This PR by OP. Let us put divided by NP and multiply with NP. PR by PN into PN by OP. Right. We are rewriting PR by OP in this form. Now if you see what is QN by ON? QN by ON. QN by ON. This is actually sine A. Right. QN by ON is actually sine A. That is this. What is ON by OP? ON. ON by OP. What is this? This is angle B. So this should be cos B, right? Adjacent by hypotenuse. This is cos B. This is actually we have made sin A cos B minus what is PR by PN? What is PR by PN? PR by PN. That is cos A, right? PR, because we have decided already that this is A. This is adjacent side and this is the hypotenuse. So this is cos A, right? This cos RPN is actually cos A, right? And what is PN by OP? PN, this one, PN by OP. OP. This is opposite side of this angle, right? In this triangle, in this triangle, in this right angle triangle, this is sine B, right? Opposite side by hypotenuse, right guys? So this is sine B. So there we are, sine A cos B minus cos A sine B, right? It's very simple, just that we drew some right angle triangles and we exploited the situation and we just use this cleverly, that we divided and multiplied with a common leg in both the triangles. Right. So that's how we are writing sin A cos B minus cos A sin B. Similarly, what is cos A minus B? Right. Now let us redo this entire thing. If this is A and this is B, what is cos A minus B? Cos A minus B is this one. Right. This is the angle that we are looking at. Adjacent side by hypotenuse. Right. That is OM by OP. Adjacent side by hypotenuse. That is this part. Now what is OM? OM is actually OQ plus QM. Right. OQ plus QM. Now let's write it like this. OQ plus QM by OP. Right. OQ by OP plus OM by OP. What is OM? OM. OQ by OP plus, sorry, QM. OQ by OM is OQ plus QM. What is QM? This is part of the same rectangle, right? The same rectangle. So QM is equal to NR. That's where we are. OQ plus QM is OQ plus NR. Same by OP. Now let us use the same trick that we did. Right. OQ by OP. What is OQ? Q is this and OP is this. Right. Let us find a side which is common to both the triangles. Both these triangles. This triangle and this triangle. Obviously it is ON. Right. ON is part of this triangle also and this triangle also. Right. So let us multiply and divide with ON. So this becomes OQ by ON into ON by OP. Similarly, NR by OP. What is this? NR, NR, NR and the same OP. Right, NR and the same OP. So what is the side common? This is a side common, right, in both the triangles. This triangle and this triangle. Right. Let us take this NP and multiply and divide this expression with NR by OP with NP. Right. This becomes NR by OP becomes NR by NP into NP by OP. Right. Now what is OQ by ON? OQ. OQ by ON. Right. This entire angle is A. Right. So this is adjacent side and this is a hypotenuse. So this is cos A. And what is ON by OP? ON is this and OP is this. So and this is angle B. So this is cos B. Right. Adjacent side by hypotenuse. This is cos B. Plus what is NR? NR by NP. NR by NP. This is what? This angle. Sine of this angle, right? What is this angle? A. So this should be sine A. Sine NPR is actually sine A. Right. And what is NP by OP? NP by OP. What is this angle? Opposite side by hypotenuse of this triangle, right? This is sine B. That's where we are. Cos A cos B plus sine A sine B. That's how we get cos A minus B. Like this. It is very simple. We just use plain geometry. Right? Plain geometry and plain formulas. Right? These results are very important. Right? These are the fundamental results of trigonometry. We use them in multiple places. It is important for us to know how did we get this. Right? This. Hope you like this. Thank you.